Bees do more than make honey. They help feed the world. Pollination supports huge portions of global agriculture, moving pollen between flowers so crops can grow. Now imagine that workforce shrinking. Fewer bees, more crop pressure, higher costs. That's one reason researchers started building something strange. Tiny flying robots inspired by insects. Not large drones, not warehouse machines. Miniature systems small enough to operate where delicate flowers, narrow spaces, and precision movement matter. At first, the idea sounds simple. Build a tiny robot, make it fly, send it to flowers. Reality is brutal. Flying gets harder as machines get smaller. Battery size shrinks. Power disappears quickly. Wind becomes a serious enemy. Tiny movements become major instability problems. And every gram matters. That means engineers have to solve lift, control, sensing, and endurance inside an unbelievably small package. Some designs use flapping wings instead of propellers, copying how insects generate movement and maneuverability. Those wings beat rapidly to create lift while allowing quick directional changes. Left, right, hover, correct. All in tight spaces. Now imagine one working. Interesting. Imagine hundreds working together. Different story. That's where swarm behavior becomes powerful. Instead of relying on one expensive machine, many smaller units can spread across an area, divide tasks, and continue operating even if some fail. One unit goes down, the mission continues. That model already exists in nature. Bee colonies don't depend on one bee. They depend on numbers, coordination, and constant motion. Robotic swarms aim to do the same. Possible uses go far beyond farms. Greenhouse pollination, environmental sensing, searching tight disaster spaces, inspecting dangerous zones, monitoring areas too risky or too detailed for larger drones. Small size creates access, and access creates value, but there are major limits. Tiny batteries mean short operating times. Outdoor wind can overwhelm miniature flyers. Mass production must become cheap enough to matter. Navigation has to remain accurate around trees, crops, structures, and other moving units. Then there's coordination. One robot is robotics. 1,000 robots is traffic control. Now, zoom out. The real importance of robo-bees may not be replacing every natural bee. Nature is still better at being nature. The larger shift is proving that useful machines can become extremely small, numerous, and cooperative. That changes how people think about robotics. For years, many imagined one giant robot doing everything. The future may look more like thousands of tiny machines doing one thing each, quietly, everywhere. And once technology becomes small enough to disappear into the background, its impact usually gets much bigger. Because the most powerful systems aren't always the largest ones. Sometimes they fit in the palm of your hand. Sometimes they arrive as a swarm.